Okay, welcome back. And in this class, actually, we will see the atomic structure. As you all know, the atom is the basic component of any material. So the atomic structure has got a great relevance in the study of these materials. Okay, in the due course of time, actually, we will see the various atomic models developed by various scientists, and what are the various disadvantages which led them, which led them outdated. Okay, so before going into this, let's see that atom consists of a very small nucleus. Okay, this is a nucleus which is composed of protons and neutrons. Okay, this one consists of protons as well as neutrons. This is a center mass, that is nucleus. Okay, and the electrons which encircles this nucleus. Okay, this is the basic structure which we have studied in the schools and all. Actually, there is a slight variation in the present model which we will see. Okay, before going into this one, let us see what is an atomic number. Okay, atomic number denotes the number of protons present in the nucleus. Okay, now how many protons are there in this nucleus? So that's one. So the atomic number ranges from 1 for our hydrogen atom and the 92 for the uranium atom. Okay. The next one is the atomic mass. So atomic mass is defined as the sum of the masses of the protons and neutrons. So this protons has got a certain mass and the neutron has got certain mass, and the total mass of an atom is considered as a sum of the mass of proton and sum of the mass of the neutrons. And actually we will not consider these electrons here much, because the mass of the electrons is very less in comparison to the mass of the neutron and proton. That's why. So although the number of protons is the same for all atoms of a given element, the number of neutrons may be variable. Okay, sometimes for same atomic mass or the number of protons, even though it is same, the neutrons can vary. So thus the atoms of some elements have 2 or more different atomic masses, which is called isotopes. So this is a general information regarding this isotope, so please keep it this one. So mole is a usual word which we used to hear. So what is meant by a mole? Okay, like mole, for a best example is like we will call it as a dozen. Okay, dozen. What is a dozen? Dozen means a number of 12. Okay, for any items, for a 12 numbers we will call it as a mole. It's a dozen. Similarly, so 1 mole of substance is like 6.023 into 10 raised to 23 Avogadro number. This is known as Avogadro number. So this much Avogadro numbers of a substance is called as a mole. Okay, so please keep this one in your mind. So this is particles like neutron. Its charge is neutral. Proton's charge is plus 1.6 into 10 raised to minus 9. So electrons is minus 1.6 not 2 into 10 raised to minus 9. So here you can see the mass also. The mass of neutrons and protons are almost same, but whereas the electrons is very small in comparison to these neutrons and protons. So let us see the next one. So this is the next atomic model which we are going to see, the first atomic model we are going to see. So these atomic models, as I said earlier, it has been derived throughout the history of the atomic physics that the period is from 19th century to the first half of the 20th century. During that time, the researchers were actually competing each other to develop this atomic model. Okay, very many Nobel prizes were announced for this model. So the researchers were actually running behind the formulations of such models. Among the first one is known as Daltons Model. Okay, as you can see, it is like the representation is just like a solid sphere. Okay, we will also call it as a solid sphere model or a bowling ball model Okay, just a sphere to represent an atom. So that's what John Dalton did. Okay, this model was actually developed in 1803, and all the matter is composed of very small sphere-like particles. That's what Dalton said, and from this one actually Dalton formulated atomic theory. Okay, in which he stated that all matter is made of atoms. Atoms are indivisible. That means it cannot be divided into small particles. During that time, like electrons or protons or neutrons were not discovered. So he was the total boss. Dalton's theory was the total boss, and he told that atoms are indivisible. It cannot be destructed. And the next point here he formulated is that all atoms of a given element are identical in mass and properties. Okay, if you consider one element, so it has some atoms, so all the atoms are same in mass and properties. So compounds are formed by a combination of two or more different kinds of atoms. And like if NaCl, sodium chloride, is a compound, it consists of the atoms of sodium and atoms of chlorine. Okay, so both are combined together to form this one. So the chemical reaction is the rearrangement of the atoms. Okay, so that's where some confusion actually came. From this one, actually the other theories were developed. They said that the chemical reaction is just the rearrangement of these atoms. So it's lost, this theory or this model lost its popularity after the invention of electron in 1897. Okay. Next is the Plum pudding model. Like after the invention of the electron in 1897, the scientific community actually discarded the earlier model. So J.J. Thomson again in 1897 proposed a plum pudding model. Okay, this plum pudding model, you know this, it's look like a cake. Okay, how it is, how it lies, because he told that, like I mean 1904, before the discovery of atomic nucleus, in order to include the electron in the atomic model. Okay, what is he discovered that there is a sea of negative, or like a sea of positive charge is there, and within that one the electrons are like few electrons are dispersed within it. Okay, so it just look like a plum pudding cake. Okay, so negative particles are floating within a soup of diffuse positive charge. So this is the positive charge totally, and electrons are just floating in that one. Okay, so this model, actually the plum pudding model, was failed in 1911 after the invention of the nucleus. So this is the next one, that is here they have came up with the other model. It is known as the Rutherford model. Rutherford actually he made the plum pudding model outdated with his well-known gold foil experiment. If you can search for that one, you will get it. It's a revolutionary experiment. Okay, so I'm not going into much details of that one. Okay, what he proposed is that he proposed the nucleus to the atomic theory. There is a nucleus, center nucleus is there. That is what he proposed, and he also said that the electrons are just revolving around this nucleus. Okay, so this small volume also contains a bulk of the atomic mass of the atom. So within an atom, a small volume or a small part is occupied by this nucleus, but this part carries the most bulk or the most mass of any atom. That's the finding which Rutherford again. How he found out and all, you will get this information if you go and search for the gold foil experiment. Okay, now he described the atom as consisting of tiny positive masses surrounded by a cloud of negative electrons. What he told that, like there's a center, positive mass is there, okay, and a cloud is there surrounding the positive mass, and there you can find the electron. Okay, but he proposed the planetary model. That means how the planets are revolving the sun. Okay, similarly the electrons are revolving our what our nucleus. Okay, that's what he explained. But how this system failed, okay, that's the most important thing. But he doesn't give any information about the energy emitted by any atom. Okay, if you know X-rays, if you know like some other emissions, photonic emissions are there. Okay, how that emission is coming out from any atom? He failed, or his model failed to explain these things. That made the failure of this Rutherford model. Okay, if some energy is emitted, like see, if you see this figure, you can see that some energy is emitted, it's gone out. But if it's going out means what will happen? The electrons will lose its energy, and what will happen? It will just spiral and just collide or fell into the nucleus. Okay, that's what that is the disadvantage of this atomic model. Okay, now after this model, the next Bohr came up with a new model. Okay, before going to this one, let's read this one. The motion of the electrons in the Rutherford model was unstable because according to the classical mechanics and electromagnetic theory, any charged particle moving on a curved path emits electromagnetic radiation. Thus, the electrons would lose energy and spiral into the nucleus, which we described earlier. Okay, now let's see. In 1913, Bohr proposed the quantized shell model of the atom to explain how electrons can have stable orbits. Okay, he came up with the quantized model. What's a quantized model? Quantized model means that there's a center nucleus is there, and around the nucleus there are certain orbitals or energy levels. So that orbitals, why it is known as quantized shell? Because these orbitals have a specific amount of energy, like N1, N2, N3. Okay, so if an electron have this much energy, it will lie in this shell. So if it has more energy, it will go to the next shell, and if it has more energy, it will go to the higher or outside shell or the valence shell. So that's what he explained with this one. And if any electron emits energy, that's a photon, or energy is emitted, what will happen? It will just fell down, or it will come down to the next level or inner orbital. That is what he explained. That means electron may change energy, but in doing so, it make a quantum jump either to allow higher energy. That means if it absorbs, it will move to the higher energy level. If it emit, it will come to the lower energy level. So this atomic model or this Bohr's model was very much successful and was in our scientific community for a long period, because it already explained all the aspects of an atom, like the emission of energy itself. Also, he was successful in doing. So this was the basic difference between the Rutherford model and a Bohr's model. In Bohr's model, if an electron loses energy, it will come to the next inner level, and if it accept or receive any energy, it will move to the higher energy level. But Rutherford failed to explain that. If it loses energy, it will spiral and just get into the atom, this nucleus, or collide with the nucleus. That's the major disadvantage of the Rutherford model. So this was Bohr's model, like it was based on the principal quantum number. We will see what is the quantum numbers in the next model. So please keep it in mind that Bohr's model is only based on the principal quantum numbers. Okay, for the quantized energy of electron, that means if it accepts energy, it will move to the higher energy level. If it loses, or the electron loses energy, it will fall back to the original level. So The electrons are quantized, which means that electrons having a specific energy falls in a specific orbital. So that is what atomic model tells us. So finally we will see what is a quantum mechanics model. Okay, this is the most realistic model ever found, and this is the, like, for the time being in 2020 also, like, we are following this model. Okay, what is this model tells us, or what is the failure of Bohr's model? Bohr's model was formulated on the basis of classical mechanics, whereas quantum mechanics model was formulated on the basis of quantum mechanics. That's the basic difference. So, like, let us see what is a quantum mechanics and a classical mechanics. In classical mechanics, electrons are considered just as a particle. Okay, but in quantum mechanics, the electrons have dual character. Okay, because it will act as a particle, also it will act as a wave. Okay, so it is also known as a wave mechanical model, in which the electrons is considered to exhibit both wave-like particle and a wave-like nature and a particle-like nature. Okay, like, suppose, before going into that one, let us see this also. With this model, an electron is no longer treated as a particle moving in a discrete orbital. Okay, Bohr's model, we assumed it as a particle revolving around a specific path or an orbital, but here we will not consider it as a particle, but rather the position is considered to be the probability of electron being at various locations around the nucleus. Okay, like, we will say, we will came up with a new word, that is probability. We can see that, like, there is a nucleus inside and an electron cloud is there. Okay, just an electron cloud is there. You can see, we will call it as an electron cloud, because why it is called as electron cloud? Because we can say that we can say the probability of finding electron at any certain position. Sometimes it can be found here, sometimes it can be found here, sometimes it can be found here, or sometimes it can be found here. At some places we can found the electrons. Okay, based on this graph we can explain. So this is a nucleus and there is an orbital electron. Based on the Bohr's model, like, this is the distance from the nucleus. At the Bohr's, we can see at only a certain place, only this place only we can see. So the probability is 100%. But coming to the quantum mechanics model, this is entirely different. Okay, what it says, there's a probability, so the maximum probability is here, but at this places also there is some chance. Can be seen here, can be seen here, can be seen here, can be seen here. At many places it can be seen. So this is a probability based. So it's a wave-like. So this model actually came after the popular advancement of quantum mechanics. Okay, that means the dual character or dual nature of the electron, after the development of the dual nature of the electron. Okay, now let us see what is quantum numbers and all. Okay, this is our 4 simple numbers. Just understand that one. Okay, like, it is just like beyond the scope. So you can just hear this one, and sometimes if it is asked, you can write for the exam also. But just hear what is quantum numbers. Bohr and de Broglie clearly established that electrons take on different discrete energy levels, as we have seen in the last. So they are related to the atomic radius. Their model was relatively simple also. So in Bohr's model, it is developed, like we told, that it is based on principal quantum number. That means discrete energy levels. Okay. However, there was no numerical means of classifying adding aspects of electrons' motion in space, such as the orientation of direction. That because the electrons have a certain orientation, like, means it will spin around a certain direction and all. Such information were not added to the Bohr's model, or Bohr's model failed to explain such kind of things. And why this model, this quantum mechanics model, was successful in that? Okay, how the quantum mechanics? If you see the Schrodinger equation, so this is the Schrodinger. He is an Austrian physicist. So he developed this one. This is a Schrodinger equation. This is the eigenvalue equation. This represents H psi is equal to E psi. I will explain what is H. H is a Hamiltonian operator, which this is like a differential operator. So this consists of kinetic energy terms, potential energy terms, electron repulsion, electron-neutron attraction. Many terms are there. Psi is the wave function, like wave-like behavior, mathematical function to represent the wave-like behavior, and E is the energy value, okay, or ground state energy. Okay, this is the Schrodinger equation. Just keep it in mind what is meant by the Schrodinger equation. So this Schrodinger equation represents the is the basis of our quantum mechanics model. Okay, so here in Bohr's model there was only the principal quantum number, but in quantum mechanics model there are 4 quantum numbers: N, L, ML and MS. Let us see one by one what these quantum numbers represent. The first one is principal quantum number, and this thing we have seen in our previous model, or the previous model, that is Bohr's model. Okay, this represents the quantum number described to the electron shell or energy level of any atom. If the value of N ranges from 1 to the maximum shell, which is the outermost electron of that atom. For example, if you consider cesium has 6 orbitals. Okay, so its value ranges from 1 to 6. So next is known as azimuthal or angular momentum orbital quantum number. So what that one? Okay, I think you must have studied the various types of orbitals in around this path or the nucleus. Orbitals I will explain like it is the place where the probability of the finding an electron around a nucleus. Okay, this is the s orbital, and if it is p orbital it looks like this dumbbell shape. D it looked like this. F it looked like this. Means for a s orbital you can find anywhere an electron within this sphere. If it is a p, you can find it here, you can find it here, you cannot find it here. If it is D, like these places you can find. So F, these places you can find. Okay, if L is 0, it is an s orbital. If L is if L is 1, it is a p orbital. If L is 2, it is a d orbital, and if L is 3, it is a f orbital. Okay, so in chemistry the orbital quantum number is very important, since it specifies the shape of the atomic orbital and strongly influences the chemical bonds and the bond angles. Okay, this is all related to the chemical part of the chemistry part. I'm not going much deep into this one, but just a peripheral knowledge says that the quantum number, that is azimuthal or angular or orbital quantum number, deals all with the orbitals, because it gives the information about which orbital is present here. Okay, so this is what the azimuthal quantum number tells. And the next one is known as magnetic quantum number. The magnetic quantum number describes the energy level available within a subshell. Subshell means like SP or like that subshell, and like these are the SPDF. These are subshells, and yields the projection of the orbital angular momentum along the specific axis. Because here this word actually we need to focus. Okay, this is the energy levels available within a subshell. So that's the information which is get from the quantum number, and also the projection of our previous orbital angular momentum along a certain axis. Okay, the last one is the spin projection quantum number. Okay, spin projection means there are, as I told before, there are 2 directions in which it can be rotated. That's known as the spin of an electron. Electron have certain spin. So the spin quantum number or the spin information can be obtained from spin projection quantum number, that is known as ms. So the value ranges from minus s to the s. Okay, so these are the 4 quantum numbers. That is, principal quantum numbers deals with the discrete energy levels. The angular quantum number describes about which orbital it possesses. Magnetic quantum number gives the information about the energy levels of the subshells, and the projection of this angular momentum quantum number along certain axis. And spin quantum number tells about in which direction or the information about the spins. So these are the various quantum numbers and various models. So please keep in mind that this quantum mechanics model is the present or the realistic or the most accepted quantum numbers, and this model helped to resolve many issues and many advancements in the field of chemistry and physics and the material science was now able because of this quantum mechanics model. Okay, thank you for the attention.